Something happened out in deep space that no one was prepared for. A new image of the interstellar comet Threeey Atlas just revealed a triple-tail configuration that shouldn't exist, not at this stage of its journey, and not under any known laws of comet physics. One tail pointing straight at the sun, two more stretching in opposite directions, each with its own structure, clean, sharp, and impossibly stable. Astronomers expected the comet to calm down after its closest solar pass, but instead, it did the exact opposite and delivered a sight that has the scientific community scrambling for explanations. And the strangest part? This isn't just another comet behaving strangely. This could be the most unexpected development in the entire saga of Threeey Atlas. The moment the Thailand photograph surfaced, everything about Threeey Atlas shifted. Observers expected a fading, quiet comet coasting away from the sun, but instead, the image showed something no one saw coming. A sharp anti-tail slicing inward toward the sun, while two separate tails stretched outward in perfect contrast. The ion tail looked thin and electric, the dust tail spread wider and softer, and between them, that razor-clean anti-tail held its shape as if carved into space. It wasn't messy, it wasn't breaking apart, and it wasn't fading the way a comet's structures normally do after perihelion. For astronomers, this wasn't just unusual, it broke almost every expectation for this stage of the orbit. And as they studied the image more closely, one question kept repeating. How is this thing still producing a tail that should have disappeared weeks ago? By the time a comet swings past the sun, its anti-tail is supposed to be fading into nothing. The large particles that create the effect normally spread out, lose definition, and drift away from the narrow plane that makes the anti-tail visible. In simple terms, it's a feature with an expiration date, and Threeey Atlas should have reached that point already. But when astronomers looked at the Thailand image, the anti-tail wasn't fading, it was sharpening. The structure looked cleaner than it did before perihelion, almost as if something was actively maintaining it. This wasn't normal solar radiation pressure, and it wasn't the slow dispersal that every comet experiences after its closest solar pass. Something was keeping those heavy particles in an organized stream long after the window should have closed. And if traditional physics can't explain that, then the real question becomes, what's driving it? Once astronomers accepted that the anti-tail shouldn't exist, yet clearly does, the search for explanations began. The first possibility is brute force. The comet might be releasing massive dust grains, millimeter-sized or bigger, in quantities far larger than normal. These heavy particles don't respond quickly to sunlight, so they cling to the orbital plane and form a sharp line. But the catch is obvious. To keep that line so clean, the comet would have to be ejecting huge amounts of material non-stop, almost like it's dumping rocks into space. The second explanation is even stranger. Instead of dust, the anti-tail could be made of icy fragments, chunks that break off before sunlight accelerates them. These pieces act like tiny temporary comets of their own, reflecting light strongly before drifting away. It's a neat idea, but fragments like this aren't supposed to survive long after perihelion, let alone hold their shape this well. Then there's the third possibility, the one researchers can't ignore. The tail might be shaped by jets that aren't chaotic like normal comet outflows, but focused, almost organized. This doesn't imply anything artificial, but it does mean the nucleus might have stable internal structures or fractures that channel material into consistent, controlled streams. And when you combine that with two other tails pointing outward, the configuration starts to look less like random comet physics and more like a system with patterns no one fully understands yet. 3. Atlas didn't suddenly become strange. It's been unusual from the moment astronomers first laid eyes on it. This latest triple-tail display is just the newest chapter in a long list of anomalies. Earlier observations showed a jet pointing straight toward the sun, something incredibly rare because jets normally rotate with the nucleus. but this one stayed locked in place, refusing to move as the comet spun. Then came the unexpected acceleration, tiny but measurable, hinting that forces beyond gravity were nudging the comet off its predicted path. Even more surprising, the nucleus survived perihelion with barely a scratch. Most comets lose material in violent bursts when they get that close to the sun, but Atlas stayed intact and kept pushing out gas as if nothing had happened. And the ion tail? Instead of fading when solar heating dropped, it expanded, spreading farther than models predicted. None of these signs alone break the rules of comet behavior, but together they create a pattern scientists can't brush aside. It's as if this object keeps operating just outside the normal playbook, revealing new layers of mystery with every stage of its journey. And the Thailand image didn't simplify anything. If anything, it made the picture more complicated. When researchers zoomed into the Thailand image, the details only deepened the mystery. The anti-tail wasn't just visible, it was precise, like a narrow beam cutting straight toward the sun. Its edges were clean, almost engineered, standing out sharply against the surrounding coma. Next to it, the ion tail stretched thin and ghost-like, while the dust tail formed a softer, broader plume. 3 separate structures, each behaving differently, yet all appearing at the same moment. What truly stunned astronomers was how unchanged the anti-tail looked. It had the same crisp definition it showed before perihelion, even though that should have been the most chaotic part of the comet's orbit. After a close solar pass, comets usually quiet down, their structures loosening and fading as energy decreases. But Atlas didn't follow the script. Instead, it held onto a tail that should have dispersed into nothing weeks ago. This consistency suggests internal conditions that aren't normal, either unusual materials inside the nucleus or processes that release particles in a way scientists don't fully understand yet. And every close look at this image raises the same unsettling thought. Whatever is happening inside this comet isn't following the rules we know. To understand why Threeey Atlas is acting this way, astronomers turn their attention inward, to the materials hidden inside the nucleus. If this comet formed far from its original star, in a region colder than anything inside our solar system, its interior might contain exotic ices that behave very differently from water. Substances like carbon monoxide or molecular nitrogen can sublimate at extremely low temperatures, releasing gas and dust long after a comet has passed the sun. That idea lines up with earlier spectroscopic readings that detected unexpected carbon-based molecules around Atlas. These aren't the kinds of materials you find in most local comets. Instead, they hint at an object built in a frozen, distant zone of a completely different planetary system, somewhere where strange ices could easily form and remain stable for billions of years. If Atlas is carrying a mix of these volatile substances, it would explain why it continues ejecting large particles even as it moves away from the sun. It would also explain why its anti-tail refuses to fade. This isn't ordinary cometary behavior. It's the signature of an object shaped by physical conditions we almost never see close up. And if that's true, then every tail it forms, sharp or diffuse, is a clue to the environment of another star. Just when everyone thought the Threeey Atlas mystery had reached its peak, the final set of transmissions delivered something no one expected, a repeating signal, not noise, not interference, but a pattern. The signal pulsed in a perfect sequence, 3 short, 3 long, 3 short. At first glance, it resembled Morse code for SOS, but astronomers quickly realized the timing didn't match any known distress sequence. This wasn't human, it wasn't random, and it wasn't natural. What makes it even stranger? The signal mirrors the rotational intervals of the Threeey Atlas, almost as if the object is responding or communicating using its own movement as a language. Scientists are calling it the first potential synchronized cosmic message ever recorded. And the timing couldn't be more unnerving. It started exactly 42 minutes after the object released its mysterious flash of energy in the previous observations. Speculation exploded. Is this a warning, a beacon, a coded message from an unknown intelligence, or a natural cosmic mechanism we simply don't understand yet? NASA refuses to call it a communication publicly, but leaked internal notes suggest they are more concerned than they're letting on. The frequency of the signal falls within a range typically used by deep space listening arrays, almost as if the sender knew exactly what humanity would be able to detect. The strangest part? Right after the signal ended, Threeey Atlas fell silent. No rotation changes, no energy spikes, no magnetic anomalies. As if it's waiting. Waiting for what? No one knows. With Threeey Atlas heading toward its closest approach to Earth on December 19th, astronomers are entering a critical observation window. Every night, telescopes across Europe, Japan, Chile, and the United States will be trained on the comet, tracking every detail of its three tails. This isn't just routine monitoring. Scientists aim to measure particle velocities, the exact shapes of the tails, and any subtle changes that could reveal the underlying forces at work. The anti-tail, for example, holds clues about the largest particles and how they're being released. If velocities match what standard comet physics predicts, researchers might finally explain this sharp, persistent structure. But if particles are moving faster or behaving unpredictably, it could mean that Atlas is doing something completely unprecedented. Meanwhile, the ion tail will respond to changes in solar wind, and the dust tail will react to sunlight, offering a natural experiment that could distinguish ordinary processes from extraordinary ones. High-resolution spectroscopy is the key. By analyzing light emitted and reflected by each tail, scientists can determine not just composition, but also whether the particle streams are uniform, directed, or irregular. These readings will either confirm that we understand comet physics or force a serious revision of models that have been accepted for decades. Every night of observation matters. The comet's structure may evolve, the tails may shift, and unexpected behavior could appear at any moment. In the coming weeks, astronomers will watch closely, because the answers hidden in Threeey Atlas aren't just about one comet. They could rewrite what we know about interstellar objects, their formation, and the physical laws guiding them. And one thing is certain. Whatever happens next, this mysterious visitor isn't done surprising the world. Threeey Atlas has already defied expectations at every turn. From locked jets and unusual acceleration to a triple-tail structure that refuses to fade, this interstellar visitor has challenged our understanding of cometary physics at every step. The Thailand image, showing a razor-sharp anti-tail alongside two outward-reaching tails, only adds another layer to the mystery. What lies inside this comet? Exotic ices, massive dust grains, or jets so stable they almost seem controlled? Observers may soon find out, but even the best data can't erase the fact that Atlas continues to behave unlike anything seen in our solar system. Each new observation is a reminder that the universe still has surprises waiting just beyond the edge of what we know. As the comet moves closer to Earth and telescopes around the globe track every detail, scientists and enthusiasts alike are holding their breath. Will the anti-tail remain sharp? Will new anomalies emerge? And most importantly, what will Threeey Atlas reveal about the building blocks of interstellar worlds or the hidden forces shaping objects beyond our sun? One thing is clear. The story of Threeey Atlas is far from finished. Its journey will continue to challenge, surprise, and fascinate everyone watching the skies. And for those who follow closely, every new discovery is a chance to witness a cosmic mystery unfold in real time.